So in this video, I'm going to work out every single problem on the worksheet for 4.1/4.2, starting with number 1 and working our way to 12. So number 1 gives us 6 times 6 times 6 times 6 times 6 times 6 times 6. A lot of sixes. And it asks you to identify the base, identify the exponent, and then write it in exponential form. So the base, that should be fairly easy to see. It's the 6. The exponent, remember, tells you how many times to multiply the base against itself. So if you count the number of 6's being multiplied, there are 7 of them. That's the exponent. And last but not least, you are asked to write this in exponential form. And it looks just like this. Base 6. Exponent 7. That should be pretty simple, I hope. So, any questions on 1? Alright, moving on to number 2. Alright, in number 2, you're asked to do the exact same thing. And actually move it this way. You have the base, which is pretty obvious here, is 7. The exponent is the number of times you're multiplying the base against itself. 1, 2, 3, 4. That should be pretty self-explanatory as well. And then the exponential form just asks you to write the base of the exponent as 1, and that is 7 taken to the power of 4. And that is number 2. Any questions on number 2? Alright, let's take a look at 3. Just like 1 and 2, the first thing you need to find is the base, which should be fairly simple. It's -8. You can write the parenthesis or not, doesn't really matter. I'm going to write it just to make it consistent. And the exponent is the number of times you're multiplying the base against itself. 1, 2, 3, 4, 5. So that's 5. So the exponential form is going to be -8. And exponent 5 right here. And that's that for 1, 2, and 3. Any questions on any of those? Alright, if not, let's go ahead and move on to number 4. So in number 4, you're asked to do something a little bit different. Well, the first two parts are the same. Identify the base, identify the exponent. And here it's even simpler because the base is the big number. That's 10. The exponent is that little number on the top right. Right here. That's 2. And then you're asked to simplify. So what is 10 squared, or 10 to the second power, mean? Well, the exponent tells you multiply the base this many times. The exponent is 2, so you have to multiply the base against itself twice. 10 times 10, which equals to 100. And that's all number 4 asks you to do. So that's pretty simple. Questions? Moving on to number 5 then. In number 5, you're asked to simplify this particular exponential form. It's similar to number 4. And the base, in this case, because there's a parenthesis, is going to be -4. Again, you can write the parenthesis around that if you want. You don't have to. The exponent is that little guy on the top right corner, which is 3. So when you simplify this, the exponent tells you multiply the base against itself 3 times. And that's going to equal out to -4 times -4 is a positive 16. Positive 16 times a -4 is going to give you a -64. So that is number 5. Let's take a look at number 6. In number 6, there's a bit of a trick, and you have to be very careful here. I have a -6 taken to the second power, but there's no parenthesis, and the exponent only observes and respects whatever it's attached to, unless there's a parenthesis to tell it otherwise. So here the base is 6, not -6, because the exponent does not see that negative. There is no parenthesis, unlike the number 5, to tell it, hey, you got to respect the negative inside there. There is none of that for number 6. So the base is 6. The exponent is 2. That part's simple. So when you simplify this, the exponent 2 tells you to multiply the base against itself twice. 6 times 6. But don't forget, this negative right here didn't go away. It's still there. So you have to write it out at least once. Not at least, exactly once. So -6 times 6, that's a -36. Questions on number 6? Because that could have gotten a little confusing. Alright, then I want to go ahead and move on to number 7. Okay, in number 7, you have a similar case to numbers 4 and 5. The base is that entire fraction because it's in the parenthesis. So 1/2, and you can write the parenthesis around it if you want. And the exponent is easy enough to spot. It's the 5. So when you have to simplify this, the exponent tells you multiply the base against itself 5 times. So multiply the half against itself 5 times. I'm not going to write the parenthesis just to save space. It's 4, and that is 5. On the numerators, 1 times 1 times 1 times 1 times 1, that's just 1. In the denominators, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And that is the answer. Let me know if you have any questions on number 7. Let's take a look at 8. And number 8 is the tricky version of number 7. Yes, you have a fraction, but unlike number 7, you do not have a parenthesis around the entire fraction. So when you apply an exponent to either the numerator or the denominator, in this case I've applied it to the numerator right here, that exponent only sees the numerator. It does not see the divide by 3 part. So the base here, just 2, not 2 over 3. The exponent is once again easy enough to see, 4. So when you simplify this, and this is one of the trickiest ones to write, the exponent tells you multiply the base against itself 4 times. So we can do that. 2 times 2 times 2 times 2. But the denominator never changed. It's still a 3. It's unaffected. Like that. One of the trickiest ones to work with are problems like this. So here, the 3 never got affected, so 3 just stays as was. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. And you can convert that into a proper fraction if you so desire. That's going to be 5 1/3. I'll write this real small here, 5 1/3, but you don't have to. So any questions on number 8, because that one is a little tricky. Alright, let's take a look at 9. Number 9, very simple. We have a rule. Anything taken to the 0 power is 1. So 7 taken to the 0 power is 1. 12 taken to the 0 power is 1. Negative 11 taken to the 0 power is 1. Not negative 1, just 1. 15.6, decimal doesn't matter, 1. Big number doesn't matter, 1. Except if it's a 0. 0 taken to the 0 power is still 0. Everything else taken to the 0 power is 1. So just keep that rule in mind, and problems like these should be super simple. Any questions on number 9? Alright, let's work on our last 3 problems. So with number 10, you have to simplify 3 of the exponential forms that I gave you, and then just crunch the numbers. And we're working with negative exponents here. So do remember that the big deal with negative exponents is that the first step is to take the inverse of the base, or flip the base. The inverse of 3 is 1 over 3. The first step is for us to take the inverse of the base. The exponent sticks to the base, but in the process changes its sign to its opposite. So it was a negative 3, becomes a positive 3. So our base changed. It went to its inverse, or flipped. The exponent follows the base, and in the process turns positive because it changes its sign. And then you're essentially being told to do this. 1 over 3 times 3 times 3, which is 1 over 27. That's the first part. The second part, same thing. You have a negative exponent. The first thing is to flip your base, or take its inverse. So the inverse of 7 is 1 over 7. The exponent sticks to the base but changes its sign to its opposite, so it turns positive in this case. And now the exponent tells the base, multiply yourself against yourself twice, but the 1 here is not part of the base, so that just stays 7 times 7, which is 1 over 49. Just like that. The next problem, we have a fraction, and in the fraction you're doing the same thing. You're going to be flipping the exponent here. The inverse of this entire base, because the parenthesis tells you that everything inside here is the base, is 5 over 4. The exponent sticks to the base, and this is the entire base, so the exponent doesn't have to travel up or down. And the opposite of negative 2 is 2. So you had 4 over 5 to the negative second power, same as 5 over 4 to the positive second power. That's not so bad. Now the exponent tells you multiply the base against itself twice. So 5 over 4 times 5 over 4. 5 times 5 is 25. 4 times 4 is 16. You can convert it into a proper fraction if you want. You don't have to. So that was number 10. Questions? Alright, let's take a look at number 11 next. In number 11, it's pretty simple. You have to simply crunch out the numbers one at a time. So it looks complicated, but if you do it one at a time, it'll be easy. So 4 to the second power, that's simply 4 times 4. Then we have plus 3 times, we're not going to do anything there, 5 to the first power. Anything to the first power is the number itself. Anything to the 0 power is 1 minus negative exponent. We have to take the inverse or flip the fraction. So that's going to be 2 over 1. And the exponent travels with the base. Alright, next step. 4 times 4 is 16, plus 3 times 5 plus 1 is 6. There's some rudeness going on next door. And then minus, this is telling you to do 2 times 2, which is 4, because we could ignore the 2 over 1, and then the 2 times 2, that's just 4. And here we have 3 times 6, so 16, plus 18, minus 4. Let me double check that I didn't make any mistakes. Looks good so far. Yep, looks good so far. 16 plus 18, so going left to right, gives us, let's see here, that's 28, 20, 34. Yeah, 34. 34 minus 4 is 30, if my math skills held up there. Yeah, I think that's it. That's the answer. Step by step. If you break it down step by step, you'll have no problems with problems like these. No problems with problems like this. I like that. Anyways, last one. Any questions on 11? Okay, last one. 12 it is. So number 12, you're simply supposed to find the mistake that I made. And let's follow through and see what was my mistake. 12 is similar to 11. So here I have 6 to the second power. That means go 6 times 6, that's right. 4 times the parenthesis. Inside the parenthesis you have 105 to the 0 power. Anything to the 0 power is 1. Minus 12 to the first power. Anything to the first power is the number itself. So far so good. Here I'm supposed to flip because I have a negative exponent, so the 3 over 1 is the inverse of 1 over 3, and the exponent becomes positive. So that's good. No mistakes so far. I don't see any mistakes in the first step. 6 times 6 is 36. 1 minus 12. Ooh. 1 minus 12. That's a negative 11. Not a positive 11. Which means right here, I should have a negative 44. And that's going to give me 36 minus a 44 is actually a negative 8. Right here, instead of all of this is a negative 8. And negative 8 plus 9 is simply 1. So my mistake was right here. I did the calculation wrong, which should have been a negative here, and 36 minus 44 is a negative 8. Negative 8 plus 9 is just a positive 1. Any questions on 12?